The ratio of the respective areas of two similar triangles is 4 to 25. What is the ratio of their sides? Well, before we do this, let's go over a rule. And this applies to any two similar shapes. Let's say these are two squares, and the ratio of the sides are 2 to 3. So I'm going to make a ratio table. The ratio of the lengths is going to be 2 to 3, of the small to the big square. The ratio of the areas is going to be 2 times 2, or 4, 3 times 3, which would be 9. Another way to get these numbers would be to simply square the ratio of the sides. And if these are cubes, if these are volumes, then the ratio of the volumes would be the sides cubed. So for squares and cubes, the relationship is kind of easy. But say you have two cones and you want to find the ratio of the surface areas, and all they give you is that the radius has a ratio of 1 to 4. Well, if the length of the small to the big cone is 1 to 4, the area would be 1 squared to 16 squared. It doesn't matter if they're talking about just the areas of the bases or the surface areas, or just a small section of the area. These ratio rules always hold true. So let's go back to the question. We have two similar triangles. They don't really describe the triangles, but all they say is that the ratio of the areas of two triangles is 4 to 25. So the ratio of the areas is 4 to 25. What is the ratio of their sides? Well, now we have to find the ratio of the lengths. In this case, we were given the ratio of the lengths. We square it to get to area, and we cube the length ratio to get to volume. If we were to go backwards, however, we just kind of do the opposite. We take the square root of the areas. So this would equal 2, this would equal 5, so the ratio of the lengths would be 2 to 5. So make sure you practice this. This again only applies to two similar shapes, whether they're cubes, cones, spheres, rectangles, or in this case triangles. Make sure that you know the relationship. We have the length ratio is squared to find the area ratio. We take the length ratio and we cube it to get the volume ratio.